classification of elements. The classification of elements is a fundamental concept in chemistry that organizes the non-chemical elements into a systematic framework. The modern periodic table, based on atomic number and electronic configuration, is the most widely used system for classifying elements. So, development of the periodic table. Dmitry Mendeleev in 1869. Mendeleev's periodic table was one of the earliest attempts to classify elements. He arranged elements by increasing atomic mass and observed periodicity in their properties. Mendeleev's table left gaps for undiscovered elements, which he predicted based on the periodic trends. That was a very phenomenal work. Then Henry Moseley in 1913. I'm not sure about the pronunciation, pardon me if I'm wrong. His work showed that atomic number, the number of protons, is a more fundamental property than atomic mass. This led to the modern periodic table, where elements are arranged by increasing atomic number. And one more thing, if you find the pronunciation of words disturbing or pronunciation of person's name disturbing, I prefer you to learn the correct pronunciation to improve yourself. Take me as a guide or learn from my mistakes. Okay. Then modern periodic table. The modern periodic table organizes elements into rows called periods and columns called groups or families. Periods, horizontal rows 1 to 7, represent the energy levels, shells of electrons in atoms. Groups, families, vertical columns 1 to 18, group elements with similar chemical properties. There are several important groups such as alkali metals, highly reactive metals with 1 valence electron, alkaline earth metals group 2, reactive metals with 2 valence electrons, then transition metals group 3 to 12, metals with variable valence electrons, then halogens group 17, highly reactive non-metals, noble gases, inert non-reactive gases. Then some aspects related to periodic trends. Periodic trends. Understanding periodic trends is crucial in the classification of elements. So, atomic radius decreases across a period left to right due to increasing effective nuclear charge. Increases down a group due to additional energy levels. Once again, I'm going to repeat. Atomic radius decreases across a period left to right due to increasing effective nuclear charge. Increasing down a group due to additional energy levels. The ionization energy increases across a period and decreases down a group. It is the energy required to remove an electron from an atom. Then electronegativity increases across a period and decreases down a group. It measures an element's ability to attract electrons in a chemical bond. Then metallic character decreases across a period and increases down a group. Metals are found on the left and center of the periodic table, while non-metals are on the right. And applications of periodic table. Chemical predictions. The periodic table helps predict the chemical behavior of elements, including their reactivity, bonding, and formation of compounds. Then elements of discovery. It guides scientists in the search for new elements which are expected to be identified and fit into the periodic table used based on their atomic properties. And material design. Understanding the periodic table aids in designing materials with specific properties for various applications such as electronics and material science. Then stoichiometry. Stoichiometry is a fundamental concept in chemistry that deals with the quantitative relationships between reactants and products in chemical reactions. It involves the use of balanced chemical equations to determine the amounts of substances involved in a reaction. Key concepts of stoichiometry. Balanced chemical equation. Stoichiometry starts with the balanced chemical equation where the number of atoms of each element is equal on both sides. And mole concept. A mole is a unit used to count entities, atoms, molecules, ions in chemistry. 1 mole contains Avogadro's number. That means 6.022 into 10 raised to 23 of entities. Then molar mass. It is the mass of 1 mole of substance expressed in grams per mole. Then stoichiometric coefficients. These coefficients in a balanced equation represent the relative number of moles of reactants and products. Then stoichiometric calculations, mole to mole conversions. Given the moles of one substance, you can calculate the moles of other substance using stoichiometric coefficients. Then mass to mole conversion. Convert the mass of a substance to mole using molar mass and then use stoichiometry to find moles of another substance. Then volume to mole conversions. 4 classes. You can use the ideal gas law to convert volumes to moles. Then limiting reactant. Identifying the limiting reactant helps determine the maximum amount of product that can be formed in a reaction. Then percent yield. It is a measure of how efficiently a reaction produces the desired product. It's calculated by comparing the actual yield to the theoretical yield. Then applications of stoichiometry. Chemical synthesis stoichiometry is used to calculate the amount of reactants needed to produce a certain amount of product in chemical reactions. Then quantitative analysis. In analytical chemistry, stoichiometry is employed to determine the concentration of a substance in a sample. Then environmental chemistry. Stoichiometry is used to assess the environmental impact of chemical reactions such as pollutant formation and degradation. Then pharmaceuticals. It's crucial in pharmaceutical chemistry for drug formulation and quality control. So in conclusion, the classification of elements and stoichiometry are fundamental concepts in chemistry that underpin our understanding of the behavior and interactions of chemical substances. These consequences have good applications. Next topic we will be learning with the help of next video.